Hello, I'm Dr. Lawrence W. Moore, and this is Learn Synthesis with Pure Data, Series 2, Episode 1. In Series 1, we started straight from scratch in learning the open source programming environment Pure Data and in learning the fundamentals of synthesis. We began with an overview of Pure Data and its different objects and how it works. And then we began building things like multi-oscillator sets and exploring different ways to make the different basic waveforms. Then we went on to continue building a full-fledged monophonic synthesizer that had all the basic standard modules that you should know about in fundamentals of synthesis. Basically, we made a MIDI interface so that you could use a MIDI controller to control the synthesizer. We made multi-oscillator modules so that you could call up different waveforms. We made tremolo and vibrato-based LFOs. We made filters, and we also made an ADSR envelope to control the amplitude shape of the synthesizer. If any of these terms are new to you, you might want to watch that full series because it covers all these basics and fundamentals of synthesis. If you already know a good deal about synthesis, but you're a little new to Pure Data, I would still recommend that you watch Series 1, Episode 1, and at least see my background on Pure Data, where basically we build a simple recording mechanism, but we start straight from downloading the software where you can get it and some things about the software. In this series, we're starting straight from scratch in building some new things that are a little bit more advanced in synthesis. And we're going to start building from scratch. So if you're new to Pure Data, you might want to at least see that Episode 1. That being said, these first few episodes are going to be a pathway to granular synthesis. We're going to make a granular synthesizer that you'll have a lot of fun with and playing with. It'll be very useful. And in order to do that, we're going to do it in a few episodes, step by step, so you understand all these different concepts leading up to it. And in building this synthesizer, you'll also learn some other things, other techniques that you'll be able to employ in other instruments and other things that you make in Pure Data, and understand some of these deeper electronic music concepts. So, without further ado, let's get started. In this first episode, we're basically going to be making a looping sampler. And that's going to teach us a lot of basics about a number of things, but it's going to give us something that we can build on to make a granular synthesizer. Okay, so here we are. I have Pure Data open. I am using PD version 0.52. I think 0.53 is out at the time of making this video, but I haven't updated yet. I might, but right now I know that all the things that we're going to be making will function in any recent version of Pure Data, and that could be going back a few years. One thing you may want to think about with the version of Pure Data that you download is your computer's operating system and processor, because I know in recent years Macintosh has switched to different brands of processors, and so you need to make sure that whatever version you're using supports your processor. And that's just an example. It could be for Linux and Windows, different considerations as well. I'm using Windows 11 right now, and 0.52 is working great for me. So But you can also find out more if you go to puredata.info. And once again, I start from scratch in downloading the software and showing the basics of it in episode 1 of series 1 in the overall Learn Synthesis with Pure Data series. So what I'm going to start by doing is making a new patch. File, new. And so here's our patch window. I'm going to make sure we have a bit of real estate here, because I like things to be somewhat neat and organized as I build. And one of the first things I do when making a new patch is to give it a home. Even though I didn't make anything yet, I'd like to save it on disk. So I'm going to go up to File, Save or Save As will work since it hasn't been saved yet. And I'll save it straight to the desktop. I'm going to make a new folder here on the desktop. It's good for you when you're building things to arrange them in folders. So there might be times that you're using multiple PD patches as part of the same overall build of what you're making. And so then it's fine to have them in the same folder. But this one, I'm going to give it its own folder. And that's going to be called episode 1. Each week, I'll keep a log of each patch that I make. I do not upload these to the to my website, because I do basically use these in teaching, and I don't want the assignments already pre-done. I want people to build with me. And so if you teach courses in synthesis, you can utilize my videos, because I don't put my patches that I build out there. People need to watch the videos and build with me. So I just named it, selected the episode 1 folder, and I'm calling it Looping Sampler, because that's what it's going to be by the end of this episode. And we go to Save. Okay, I just had to pause there because I needed to cough. So anyway, let's begin. First thing I'm going to make is an array. Now, as you may know, under the Put menu is a list of different things that you can put as far as your build is concerned. And an array is one of them. It's always at the bottom here in the list, but it has a shortcut, Shift-Control-A. I believe that would be Command-Shift-A in Mac. Usually anything that has a shortcut of Control in Windows is going to have the shortcut of Command for Mac. And we're going to name this array. You always want to name your arrays. And this array is going to be used to hold the waveform that we're working with. And so I'm going to call that $0 underscore waveform. Now, once again, I just want to remind folks about, naming things. When you give things a name or a symbol, you don't want spaces in it. If you, for your formatting, would like to see something like a space, use underscore. And try to use all lowercase, because PD is case sensitive. If I make this array capital W waveform, and then I don't use that capital W anytime I'm trying to address it, it won't work. So those are some things to be aware of. $0 I put right at the beginning of this, because $0 is a way of symbolizing to Pure Data that there should be a unique identifier put in place of that. Basically, it's called a creation variable, where when this file is loaded up, and you can load Pure Data files into other Pure Data files. Like, let's say I'm making this looping sampler and I want to load it up and put it with some other devices I make. When you have a $0 there in the names of things, Pure Data will replace that with a number, a unique number, for everything that's associated with this file. Okay, and that means this file that I named looping sampler. If I load looping sampler into something else as an abstraction, which is the term that's used for that, then all the $zeros that I use in here will have the same number assigned to them, basically to pure data. $0 gets replaced with a number. You don't actually see it, okay? But as we go, you'll see what I mean, because we'll have a week where we'll bring some things together, and the $0 will be there so that if I have two looping samplers in the same patch and I load them in, they won't have duplicate names that would cause errors to occur. All right, so anyway, its size I'm not going to worry about at this point. I'm going to let it display in points, and we'll see if we want to change any of that later. We will probably change its visual size. So this array, as it's going to be used, it will be used to house a waveform. We're going to record some sound and then have it come into the array, and then that sound's waveform will appear here. Basically, this is like a holder for multiple things. You could just use an array as a table where basically you put in some numbers and say, for example, you're going to hit Control E and go to run mode. You could put in different numbers into this thing. And so basically, as you go across the x-axis, there's different numbers stored in here that can be used for other things. Or you can use them to load sound in, because as you see here, it's almost like I drew a little bit of a sound wave. So arrays have multiple purposes. We're going to use it to load sound into it. And this is how we're going to do it. We are first going to make something that I always like to make in my patches, and that is a load bang, which basically will turn on sound. It's called DSP when the patch opens. Load bang. And then I'm hitting Control 2, that would be Command 2 in Mac, symbolizing a message box. Message boxes, as opposed to object boxes, remember? Object boxes, basically you got to type something in that is basically part of PD's language so it knows what it is. Message boxes has this little indentation to the side, and this is something that is used. You could even click on it to send messages. And the message we want to send is semicolon, then hit enter and start typing PD DSP space 1, and then end it with a semicolon. This is a message. It starts with a semicolon, and when you first start typing it, when you hit enter, you don't see it go to the next line, but as soon as you type something else, it does. So PD space DSP space 1, semicolon. This is a message that says, hey PD, that's the software we're using. DSP, or audio, should be on, which is symbolized by the 1. And so we're going to hook this up like this. Outlet to inlet. That's how you connect things in PD. Load bang to the message. That means when this thing opens, audio is going to be running. I like to have it that way so people don't have to go up to the media menu and turn on audio from here. You see DSP on, DSP off. You can do it here. Shortcuts, Control / and Control period. I assume that's Command / and Command period in Mac. All right. Now, I might want to turn sound off at some points. So what I would just use is the Command period to turn it off and Command / to turn it back on. But by the time this thing's finished, when someone opens it up, I want sound to be running so it's working right away. That's all I'm doing here, basically. And we could even send it right now by hitting Control E, Command E in Mac. Control E and Command E turns you in and out of edit mode. Here I'm explaining some of the basics of PD again, just to be safe. When you have the pointer, that means you're in run mode and you can click message boxes and do things on screen and have them happen. When you see the hand there with the finger, that basically means you're in edit mode, and this is where you build things and connect things together. All right, so anyway, now that that's done, we're going to make a mechanism for recording sound. We're going to first record it to disk and then have it load into the table. And the way we do that is we're going to make an object called writesf. So I hit Control 1, click the box down, and type WRITESF tilde. Now, what that tilde means is it's an audio object. These words like load bang and writesf tell an object what it is. It's got to be something that PD knows what it is. And the types of objects that have the tilde at the end means that they are objects that work at the audio rate. Since this object writes to a sound file, it obviously needs to function at the audio rate, which means it's got to be basically operating at the sampling rate. And in fact, we're going to set that up as part of our load bang. Everything in digital audio has a sampling rate to it. And that is something you can set in your media menu under audio settings. You can set what sampling rate you're using. I'm at 48,000, which is 48K. You could select other ones so long as the interface that you're using supports it. Most things anymore do support 48K or 48,000. So you would likely have the same settings as me, unless you're using an interface that goes higher and you really want to use that. But I'd like to make this patch usable by people with multiple sampling rates. So I am going to create another object here called sample rate. And it also has a tilde at the end. Now what this object does is it calculates or just outputs what the sampling rate is. So we need it to output to something. So what we're going to do is hit Control 3 to make a number box. And then basically it'll fill up this number box with the sampling rate. Now, what I usually like to do is make sure the number box is big enough to show it. So I right click on it, go to its properties, which appeared down here. And its width up here means how many digits wide is it. 5 digits wide would show 48,000, but let's say someone's using 192K. It's probably good for us to just put 6 digits in there to make sure it's wide enough to display, any of the common sampling rates. All right. So when we load bang, we want both of these things to happen. And so what we're going to do with load bang is give it, first of all, I'm going to click on it and go Control-Shift-B. I'm using shortcuts here, but all these things I'm making can be found in the put menu that I showed before. This is a bang. It's basically an object that sends a signal. Lots of different things receive bangs, and when they receive a bang, they do whatever they're supposed to do. It's basically a signal to do something. And so I'm going to put this here because I want to be able to, while I'm building this thing, execute whatever the load bang would do. Because a load bang only goes off and sends a bang when you open the patch. Since I'm going to be working on it here rather than closing and reopening all the time, I just want to put a bang here so that I can have some of these things that I'm making actually happen. And then I'm going to make a trigger, abbreviate that T, space B, space B. This means this bang or the load bang, which can bang through the bang that I made here, basically will send out 2 bangs. Now, you technically don't have to do this. You could connect this bang up to these 2 different things separately. But anytime I'm going to multiple things, I like to put a trigger in, and the B stands for bang. I like to put the trigger in just because it's easier for me to see how many things and what things these patch cables are going to. If you have some objects with like 5 or 6 patch cables coming out of it, going different places, sometimes it's harder to see where they're going. It's easier to follow the path from a trigger bang bang or a trigger bang 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 to all the different places it's going. And then I'm just arranging these just to look nicer. So basically, when this patch opens, the low bang bangs the bang, which sends out 2 more bangs to turn the sound on, and then to give us our sampling rate. And this sampling rate is going to be sent out because we're going to want to use this information. Basically, I'm going to make another object, type the letter S, which means send, and I'm going to just simply call it $0, because this is a name, a send, and its corresponding receive. Take a symbol name afterwards, and they need to be unique for the different symbols you're sending. I basically want to send out my sampling rate, and I'm simply going to call it sample rate. I could call it $0_Dave. It doesn't matter. As long as this thing receiving $0_Dave is able to use it. But basically, I'm calling it something I'm going to recognize, just $0_sampling rate. Once again, the $0 there is just for naming purposes, so that now that we save this, let me show you, just on disk, I could literally make another PD file and open up looping sampler twice into that file. And since I'm using $zeros as far as the names of these things, those 2 things, those 2 different instances, those 2 different abstractions will basically each put a unique number in place of $0 so that they don't cross-communicate with one another and cause interference. That's why I'm doing this to start, because later we are going to load up some multiple things that we make and put them together in a patch and use them together. And we don't want to worry about them having, conflicting names. Okay? So anyway, now what we can see here is I'm going to hit bang, and you see it puts my sampling rate there. It turned DSP on. It was already on, but sample rate got banged. So now sample rate sends out the sampling rate, which is 48,000, and that gets sent here, which isn't going anywhere because there's no receive to receive it. But we are going to use it later. So anyway, we have write SF here. All right. So what we are going to do is the way write SF works. And anytime you need to remind yourself in the objects in PD, you can right click on them and go to help. And it gives you a little help file. And a lot of times these help files show you all the different types of things that they can be sent. But basically, I only want to open up a file and then send the signal to write to it, and then send the signal to stop writing to it. Okay, so we're going to do that. We're going to make a message box that will send the message open, and I'm going to call it recording.wav. So this opens a file, and if a file doesn't exist, it creates it. If it does exist, it basically reopens it for writing to it again. Now, we started in episode 1 of series 1 in a similar way, but believe me, soon it's going to change directions. And then you need to send a message to start recording. And that means it'll start writing audio data to that file. Then obviously at some point, you do want to stop the recording. Now I want to automate this so that we could do this with one button. In fact, I'm going to put these all next to one another in a line here. We're going to clean things up and make them look smoother as we go. But right now, this is how I'm going to do it. I'm going to make a trigger, bang, 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 and then yet one more bang. Now in PD, things are read right to left, top to bottom. But there's ways that you can change the timings of some things and stuff like this. Like, first of all, the whole action of opening up the file and to start recording to it, the open needs to happen first, and then the start needs to happen at a delay after that. Now, if I were to put this to the right of this and send a bang to it from here to here, and then this to this would definitely happen before starting. But one thing is, it takes a little bit of time for it to truly open the file. So in our order of bangs here, in telling stuff to do stuff, we're going to put a delay here, making an object, delay 10. Well, actually, let's make it 100. 100 milliseconds. The number that you put after the word delay is always in milliseconds, which 100 milliseconds is a tenth of a second. Something went wrong there. You see when you get a dotted outline like that, that means you typed something wrong. Delay, space 100. Let's just make sure we only have one space there. Okay. I'm being thrown for a loop here. Just a moment. I'm not exactly sure what I was doing, but I typed delay space 100 over again and it worked. So maybe you saw what I was doing wrong there, but I wasn't sure. So anyway, we want to delay starting by 100 milliseconds. Now 100 milliseconds is so quick that when you press to record something, you're not going to notice that delay much at all. All right. And so we're going to bang, open gets banged first. And actually, I put all these bangs in here for no good reason. Sorry, let me do that again. We only need to do trigger bang, bang. We only need 2 of them. So the right one's going to go here to open, and it is already. Or, no, it wasn't. The graphics just needed to update. All right, and then the next one here will do this. Now, I said everything goes right to left in order, but the thing is, they go quickly. Like these 2 bangs will just go bang, bang, right after one another. But we need to extend how long it takes for this one to start the recording to make sure the file was properly and truly opened. Okay, so that's why we did that. And here I'm just trying to arrange this to make it look nice. You get like that after you work with PD for a bit. There we go. All right, so that it basically would initiate recording. Now we need to basically stop recording. And after we stop recording, we want to do some other things too. I'm going to move stop to the right, and then what happens next will be in between. Well, sometimes if you still have the last thing you used selected, and you press like Control-1 to make an object, it'll automatically hook it up, which can be convenient, unless you didn't realize it was still selected. So I'm going to make a trigger, bang, bang here. Now this is going to be for stopping things. So obviously the first thing you want to do is to stop the recording. But then there's something that we want to have happen right after that. We basically want to have what we've recorded to a file named recording.wav. We want that loaded into this array. And the way we're going to do that is using an object called, and it just made it below there again. Anytime you make a new object and you don't know where it is, look at the last thing you clicked on. Okay, so we're going to use an object called sound filer, which really means sound file read. It is not an audio rate object, so you don't need to put a tilde after it. And what we're going to send to sound filer is a message that tells it what to do. Now this message, I'm going to type it first of all, just so you understand what it means. And then I'm going to have to redo something because of us using $zeros. But let me show you. First of all, we're going to tell it read and then you put hyphen resize. Then you put the file name that you want to read, recording.wav, and then the table name, which will be $0 underscore waveform is what we called it. Now I'm going to need to fix something here in a minute, but I just want to explain what the message is first of all. If we weren't using a $0, we wouldn't have to do anything. But this message tells sound file read this file. But the hyphen resize is just a command argument that tells it to resize the table that we're going to be reading to be the size of this file. You see right now, if we go on to the table's properties, its size is 100. Now this is not its display size. That means there's 100 points where information can be stored, basically numbers, but they are called floating point numbers, like numbers that can have decimal points and any number of numbers before or after the decimal point. But basically there's 100 of those slots here for the numbers to be stored. That's really small. Our sampling rate is 48,000. That would only be 100 samples, space for 100 samples. That would be not even close to being even a fraction of a second. So that's what that size means. Now here you can change the visual size of the table. This is the second window that comes up under a table's properties. If you notice down, then I say tables, down then I say array. For now, for our purposes, for all intents and purposes, they are basically the same thing. But let's say I want to display this at a certain size. How about 350 pixels by 175? Don't worry about these boxes here right now. Just use the size boxes for X for width and the size box for Y for height. No, not 175. Or do I? No, let's make it thinner than that. This is like a 2-to-1 ratio. Let's go for it. You could hit apply to see how it looks or just click on it. There we go. So we made it. That is just its display size. It's now 350 pixels wide by 175 tall. But there are 100 different dots in here. You may not visually see them, and especially when we record a waveform, it won't be able to put 48,000 dots per second in for all your samples. So the way it looks and what's actually in there a little bit different. It has to approximate the shape of the waveform that's coming in. But anyway, this is going to resize. Let's say we record 3 seconds of audio at 48,000 samples per second, which is our sampling rate. That means there would eventually be 3 times 48, that's 20 plus 144,000 samples going left to right in this array. It can't show all those in 350 pixels wide, so it shows an approximation. But the data for all those samples will be in there. So that's what Resize is doing. It's making this the size of the audio file we're bringing in. And then it's writing it to this table. Now there's one thing I said I needed to fix, and that's because we're using $ zeros. The thing about $ zeros is when you type them into object boxes like $0 sample rate, it does that magic of replacing the $0 with a unique number. With message boxes, it doesn't do that, so that you have to use a bit of a workaround. And this is what I'm going to do. I'm going to put in here $1. Now, $1 by a message box is understandable. It understands that it means whatever's coming through the inlet, if it's a list or whatever, the first thing in that list, in this case, there's only going to be one thing coming in, so it's going to take that. It's going to replace this $1 with that. And what we're going to send is the following. We type the word symbol, because we're telling it this is a symbol we're sending, and this symbol shall be $0_waveform. So here, when PD opens, this $0 gets replaced with that magic number that gives it a unique identifier, because this is an object box. And it's just saying here, this thing here is a symbol, replace $1 with that. Okay, and then we can hook up the bang here. And then we could hook this up to here. So that sound file will read the sound file that comes in. And then one thing that's nice that it does is it outputs from its left outlet a number. And the number is the size in samples of the sound file that was brought in for the table. So we'll actually get a size in samples of the length of this table. Now, once again, I'm going to go to properties here and give it a whole bunch of digits. Let's give it, 5, 7, 8, 9. Let's give it 12 just to be on the safe side. Okay. And then that we're going to put in a send. I'm trying to click on this, Control-1, there we go. Because we eventually want to be able to use this information too. Send $0 underscore let's see. I'm just trying to think of a good name for this. How about sample length? All one word. There we go. So that will be defined as that. Now we should be able to try this out if I didn't make any mistakes, but we got to put in a mechanism that will do this. Since I'm going to try to start making this look nice, I'm going to put here something to click to do recording. I'm going to make an object and type the word toggle into it. And what that gives me is a toggle box. A toggle box, when you're in run mode, I'm hitting Control-E to go into run mode. You click on, it sends out a 1. We don't see it, but that's what it would send out its outlet. You click it again, it sends out a 0. So it's just a 1 or 0 sending machine. Going back into edit mode, right-clicking on it, going to properties. Let's make it bigger and look nicer. Let's make it about 25 pixels tall and wide. And we're going to give it a send symbol and a receive symbol. That way we can send messages to and from it. I don't know that we need to send messages to it, but I always put in a receive anyway. And once again, we got to use $0 underscore record. And then underscore send. Why that? Because anytime you have an object like this where there's a send and a receive symbol, they need to have different names. Record, and then I always abbreviate it, RECV. It's just a habit. I don't know why. So it's the same length as send. You could type the full word receive, but you got to make sure you keep that name later when you're sending to it. Okay, and I'm going to make its background light red. Red for record. Okie dokie. So here we have this. This is our record button. Now, we need to actually receive from that and tell these guys what to do. So we're going to put up here a receive $0 underscore record underscore send. Why send? Well, remember, we named this thing's send symbol $0 underscore record underscore send. So in order to receive from that send symbol, you need to use the same name. So your receives will, when you're using objects like this where you have send and receive at the end of the name, there you go. Now for these, for sample rate and for sample length, we don't need to put an underscore send or receive at the end of those names because these are one-way communications and we don't have to have different names for the send and the receive. Okay, so what happens when we receive a 1 or a 0? Well, we're going to send this to SEL, which means select. You could even type the full word select. 1 space 0. Now what select does is when it receives a 1, basically whatever creation arguments you made here, space 1, space 0. When it receives those, it will send a bang out the appropriate outlet. Since 1 is listed first, the first outlet will send out a bang. When we press that record and the toggle button has an X in it, it's basically on. Okay, we want it to send to here to record. And then the second outlet is when a 0 comes in, a bang will come out of this outlet, which will tell it to stop recording and then do this stuff to basically load the sound file in. One thing I just thought about with this is the same thing as with what happened before. I'm just thinking there should be a delay on this. So I'm going to put a delay 100. To make sure the recording has stopped well and truly, because at the end of stopping the recording, it also basically closes up the file. So, it recorded the data of the file, and when you stop, it closes up the file, and it may take some milliseconds before the file is ready to use. Okay, so there we go. I'm moving this stuff over. I'm going to clean this up in a bit. You'll see a nice way of cleaning things up so that we can have a better graphic user interface for this thing. all along the way as we build, I like to try and make things look nice and organized, so it's easy to see the order in which things happen, right to left, where there's delays, all that stuff. It's easy to see. Because when you stop working on this and you pick up working on it later, you might be a little bit confused to start unless you really organize things. Now, what we need to do is, first of all, we didn't give it a signal to record. So we're going to make an object, ADC tilde. This is analog to digital converter, and basically this will be our sound in. And so this sound coming in is going to go here into write SF. The sound comes in, the signal comes in to open up a file for it, and then you hit start, and start will start writing to the file. Basically all the sound coming through here will be going to the file, and then once it's going to the file, once you click this thing again and it goes to 0, it will then trigger this stuff to happen. Stop writing the file, and after a slight delay, open this file up and put it here. Now, this should work. And one thing we're going to do here is I'm going to try to open up the folder behind. Sorry if this looks ugly, but basically we're going to initiate doing this thing, and we're going to see our audio file appear here. Since we didn't put like slashes in for file folder names or anything like that, by default, wherever your patch file is, if you just type a file name for writing to, it's going to create the file right there. And we're fine with that. So anyway, let's make sure all of our stuff's on. And then we're going to record. Now, this also presumes that you've gone to the media menu and you set up all your inputs and outputs. So that's media, audio settings. I mean, you could either be on, the standard MMO, or that's Windows, or ASIO for your interface. I have to use this because since I'm using the same interface to record this video with, ASIO would steal the drivers away from it, but you would probably be best served using ASIO or a higher protocol than the standard protocol. But under audio settings, just make sure your inputs and outputs are set to what you want them to be. And they are, for me, good. So now we're going to press record, and we can talk, and we could say some things and all that stuff. Press it again. There's the waveform that we just recorded. Looks like my gain is up pretty high. Hopefully it's not too high. I did a little bit of the sound check beforehand, and wow. Just turn down the gain knob on your interface if you're seeing things that thick. But anyway, what about playing it back? Well, this is where we're going to be building a different mechanism. The first thing I'm going to do is, since I see this works, I'm going to put all this stuff in a subpatch. I'm going to make an object, and I'm going to type PD recording. I'm going to move it over here. Now I'm going to select all the stuff that deals with recording, which is this stuff here. I'm going to hit Control X, right click on this, hit open, and then do Control V. That will be Command X and Command V in Mac, your shortcuts for copying and pasting. And what I'm going to do is move this on over here. Like this. Since we're using these symbols for sending and receiving information, this doesn't need to be outside here with this. So I can close this up. We're not going to need to do too much more with that, but anytime we need to, we can right click on this and open and access it. So this allows us to keep our thing a little bit cleaner. Another thing that we can do is all this load bang stuff. We can make an object. Type PD space. That's how you make sub patches. You type PD space and then give it a name. And I'm going to call this, let's see, loading. I'm going to select this stuff. Control X. Control V. Now, just so I can keep this window smaller, I'm going to move this over. When you do that, copying and pasting, it always pastes it graphically where it appeared when you cut it. And so I want to just kind of move it over here. Like that. I might expand that if I decide there's more things that I want to have happen on load. But anyway, you can think of it this way. Loading comes first, and then next recording, and then down here we'll put our playback stuff. But I'm going to make it here now so we can kind of see and visualize things a little bit better. Now for playback, we're going to make another toggle. You know what I'm going to do? No, I'm not going to do that. I'm going to just type toggle. Right click on its properties. We're once again going to make it the same size as the record button, 25 pixels by 25 pixels. $0 underscore play underscore send. $0 underscore play underscore RECB for receive. And then I'm going to make it a light green. Alrighty then. I could put labels on these. So, in fact, let's do that. Right click on this. It has here label. That basically will appear by default. You can say where it appears, how many pixels horizontally or vertically away from the origin, meaning the upper left corner you want to place it. But it usually comes out pretty well for by default. I'm going to say record. Well, and it didn't. Probably because I resized the thing. Yeah, I resized it. Oh boy. Well, here, let's get this in place. Let's figure this out. X, horizontally speaking, we want to put it up and to the left. X is at 17. Let's put it at 0. That should get me to the upper corner of it. There we go. So it's to the left. And then Y, it is listed as 7. We got to go into negative values to get it to go above. That's just the way it works in PD. So let's say -7. And then I'm going to hit apply and see how that looks. There we go. So let's remember these. 0, -7. Because we'll use the same values for the play button here. There we go. It would have been nice if I typed in a label. Play. There we are. so it looks halfway decent. There we go. Now, this play is going to work in a similar way. You can toggle it on, and then when you click it again, playback stops. All right? That way, you don't have to have two separate buttons, play and stop, you know? You can basically click it to start playing, and then unclick it to stop it. Because this is going to be a looping sampler. So it's going to play and loop around and loop around and loop around. Now, how does this work? Well, here's the mechanism for it. We're going to use something called Phaser. Phasor tilde. Now, this is an object that what it does, it's an audio rate object, that's the tilde. And if you've seen my previous series, you know what it does. Basically, it sends out a signal going from 0 to 1 at whatever rate, at whatever frequency you have coming in through its left inlet. Its right inlet will receive phase. But its job is just to go to from 0 to 1. Now, what we're going to do is say, all right, if we were to say, multiply it by the length of this table, its output here, we could go from 0 to the end of this table. And then Phaser goes right back to 0 again. So it would basically loop this table. And that's exactly what we're going to do. We're going to put in star tilde, which is a way to multiply numbers at the audio rate. Okay. So whatever comes out of Phaser, which is 0 to 1, and remember, when it's going from 0 to 1, it's doing all these numbers in between that are floating point numbers. 0.0001, 0.00002, 0.000, you know, however many it needs to fill in to get to 0 to 1 at the frequency you send it. But now what we're going to multiply this by so that we get it to go to 0 to the end of this is what we named the end of this table. So we open this up in our recording section. Remember, we named the table. I'm sorry, I've been partially off screen this time. I don't think any of the stuff we needed to see was off screen though. There we go. That makes it look better. Okay, so remember this this loaded in the file, and SoundFiler puts out the length in samples, which it sends under this symbol. Now, the reason why it's showing 0 here is I copied and pasted it. I cut it and pasted it, and when you cut and paste, number box is always 0 out. So we could basically record again and get that number back. All right, here is our second recording. There we go. The gain didn't overdo it this time. And see there, it fills it in. And it sends it out as $0 sample length. So sample length is that number, which is here, is literally 150,848. That's the last sample in there. And if you divide that by 48,000, you'll find out basically how many seconds long this thing is. And that works out to be, since 3 times 48,000 is 144,000, it's a little bit over 3 seconds long. Now, what we're going to do is put a receive in here. I hit Control 1. Where did it make probably made an empty object box somewhere. Well, I'll eventually find it. Let's just do it again here. Control 1. Please. Okay. Receive $0 underscore sample length. So if we're multiplying the range of 0 to 1 by the sample length, we're going from 0 to the end of this file. Okay? And that's what gets outputted here. We'll do stuff with that in a second. I'm going to put another star tilde in because this is going to help us out with something else. Basically turning this thing on and off. Because I know from experience that, you know, as long as DSP's on, audio is running. And if we give phaser a value and frequency, it'll start playing. And it'll just keep doing it until, you know, the cows come home. And if we have our tape, the thing that's going to read the waveform set up, in other words, we won't hear the end of it. So we want to wait to be able to turn things on and off. And the way to do that is to send a 1 or a 0 to this star tilde here, which we can think of as an amplifier. Basically, as the stream of numbers is coming through. Oh, wait a minute. No. We're actually going to put this later. We're going to use it, but we're going to put it later. Never mind. Because at this point, what our stream of numbers are is 0 to 150 whatever thousand that number was. That's what's coming out. It goes 0 to 150 something thousand, back to 0. Okay, so that's all it's doing. It's giving us index values of the samples in this table. And then what this gets read by is an object called tabRead4. Tilde. And actually you can put into it the name of the table you're reading as a creation argument. So I'm going to go ahead and do that. $0 underscore waveform. All right. Now these index values of 0 to 150 whatever thousand, maybe I should remember that. I don't have to. 150,848. As those numbers come into tabRead will output the sample that's at that number going left to right. So you hear it's around 0 until we get to here. Then you're going to get higher numbers between a range of 0 to 1 and the 0 to -1. And so these samples are part of the sound wave. And basically tabRead takes these sample numbers and gives us sound. Now this is where I want the amplifier, because this is what will allow us to turn the sound on and off as we need to, like when we get sick of hearing it. Alrighty, so this goes into tabRead, and tabRead does its job. Okay, next. We need to tell phaser how fast to do this. Like, we basically don't really, it reads this as this left inlet as cycles per second. But we shouldn't be using normal note frequencies like 440. I mean, that doesn't work with this. Because basically this has to go from 0 to 1. In other words, it starts at 0. Phaser shouldn't get to 1 until it's had time to play out all these samples in between. Now here we see from our recording what the sample length is. So we know how long this sample is. And what we then need to do is find out a couple of things. So we're going to make another sub patch here. right after recording. We're going to call it calculations. And this is where a number of things can be calculated. And as we build this patch more and more, we'll add more calculations here. But anyway, we're going to receive $0 underscore sample length here. It's not typing what's going on. $0 underscore sample length. We're going to be receiving that here. We got to actually put the R for receive before the symbol name. There we go. So that comes in, and we might as well be able to see it. Let's put a number box below it. It helps in testing things out. So that comes in. And now our playback rate is 48,000 per second. But it could be something else for somebody else. So what we need to do is divide this by our sampling rate. So we can make a divider here. We'll probably take out the extra number boxes later, but right now it's good for the explanation. And remember, our sampling rate is being sent out under this name, $0 sample rate. Oh, gotta type R for receive. We're receiving the sampling rate. You know what? We don't need that number box above. We know what that number is elsewhere, so we don't need to actually see it here. This is just simple division. And since their sampling rate is samples per second, if we're dividing the number of samples in length that this recording is by our sampling rate, we're going to get the number of seconds plus a decimal point and, tenths and hundredths of a second afterwards. But here we will want a number. So we'll find out how many seconds long it actually is. So let's record again so all these calculations go through. Since we just made this stuff, we need to do that. Hello, let's get our calculations. And we didn't get one. Oh, I know why. The sampling rate didn't actually come in. Since all we did was press record, sampling rate never appeared here. But if we go up here, we can press this button and then sampling rate will come through. When the patch opens, the sampling rate will come through and it gets stored here. The right inlet of math objects store the number, and it's only when something comes through or a bang comes through the left inlet that things get calculated. So now that we put the sampling rate in, we can record again. And there we go. This is 1.606 seconds long. Okay, so now we know what the duration is. We might want to have that information at our hands, so we might as well create a send for that. $0 underscore duration. I don't know if at this point we're going to need it, but at least now we've given it a name, so when this gets calculated, we have it. But what we need to do with it now is basically we need to convert this into a frequency that we can give to Phaser. Now, Phaser calculates in cycles per second. So if we divide this by 1, we'll find out the cycles per second we need to operate it at for it to get from 0 to the length of the sample by the end. So we're going to do this. We're going to create a message 1. Or actually, this is another way to do it. We're going to create an object called swap 1. And then we're going to create an object below that that is a divider. And then we want to hook up this right outlet to this right inlet. Okay? Now what's going to happen here is this duration, what the whole duration of the thing is. Basically, we want it to get from 0 to 1.606 seconds at a certain rate that it plays back at the proper speed that it needs to play back at, okay, in order to get there. And that speed is basically dividing it by 1. When this number comes into the left inlet here, swap 1 will basically send it out the right outlet. And the swapping means that whatever creation argument you put here with swap 1, this number or whatever comes to the right inlet, but we're not going to send anything else. We're just going to take this one and it goes out the left outlet. So this divider receives 1 divided by this number here, and then we will get an output here. And then we're going to call this send $0 underscore because we're going to be playing with this later. We'll be changing speeds and so forth. So what we're going to call this now is going to be normal speed, all one word. Okay, that's what we're going to call it for now. Because that'll be the normal speed for it to play back at the speed it needs to play back at. Sorry, just trying to bring that thing down. Okay. So we close that. Actually, let's open it so you can see the stuff happening. But we need to create stuff here. We need to receive that normal speed. Receive $0 underscore normal speed. And what we're going to do is send that into the right inlet of a float box. The right inlet of a float box stores numbers. Float box meaning floating point numbers. Computer terminology, a float is basically a number. You just have a decimal point and all these sorts of numbers before and after it. So they call it float, because that decimal point floats around. And that is going to be our speed here. But we want it to store it there because we don't want to send that to Phaser until it's time to play. Okay? And now let's make our playback mechanism. We're going to have our select zero and 1, or could it be 1 and 0? 1, doesn't matter the order. But you got to type it right. SEL 1 space 0. Okay, so when play comes on, and remember we're receive $0 play underscore send. So when this gets clicked, it gets received here, whether it's on or off. The select 1 0 determines whether it received an on or an off. The 1 is going to tell us you should be on. Okay, and so we're going to have that do two things. So we're actually going to connect up a trigger bang bang. Let's move this stuff down so we have more space. We're eventually going to put this in a sub patch too. So we're going to bang. First thing is going to be to turn on sound. Remember, after tab read, which is outputting our audio, we have this. This is to turn on or off. I'm actually going to add an extra thing later, but let me just hook it up now so you understand the logic of it. We send a 1 to this. That means multiply everything coming through by 1, which means you get your normal volume. And that bang will go to there. Because the first thing before you can play is you got to turn that on or else you hear nothing. And this is just so the cables don't overlap and cover up things. And then the second bang will actually send what's being stored in float here, which is normal speed, which means it's going to play this thing back at our normal speed. There we go. Now, we need the opposite as well. We need to stop it. So, actually, it's the middle outlet here. The select object, the third outlet, when you have two creation arguments, is always none of the above. All right, so it's the middle one. You count over left to right, and whatever you have in the creation arguments from going from left to right, that's what it is. That's why I like to pull these things down so you could see where this is connected to. Now, bang, bang. All right. What I've always done in the past, and I'm going to try and determine whether or not, yeah, I guess it is a good idea. So it starts from the beginning. Basically, the leftmost bang is going to go to a 0. Which will go into the left inlet of float, which means it goes straight through. You send a number to the left inlet, it goes straight through. You send a number to the right inlet, it stores it and waits for a bang to send it through. So that way we could use the same float box for sending the 0 and the 1, or the number of the cycles per second. How are we doing here? Yet we're still on screen, just making sure. All right, and then the rightmost bang is going to be for turning the whole system off. Otherwise, you'll hear the tab read playing. Even if you send this 0 in, phaser is still outputting like nothing to tab read, and tab read is reading sample 0 over and over again, and you don't need that. So we put the 0 here to shut off sound. And then we need to make a DAC, D-A-C tilde, and that gives us our output. And I'm going to hook the output up to the left and the right so we hear sound on both sides. This is a monophonic. This is not a stereo sample player. You would need 2 tables for that, and then 2 of these mechanisms reading each one in tandem, synchronized with one another. Okay, so let's see what happens. Let's see what happens. And I am going to open this up, though, the calculations, so we could look at those as they happen. Okay, here we go. Will we have success? All right, so what we basically did get, these numbers did fill up. All right, so if we're playing back at 0.241 cycles per second, it should go from here to here in real time. Okay, here we go. Will we have success? Okay, here we go. Will we have success? Okay, here we go. Will we have success? We's all good. It all worked. It works, folks. It works. All right. So I am going to do one more thing because next week we're going to start granulating. I am going to, well, apart from this is just housekeeping. Control 1. There you go. PD, playback. We're going to put this stuff in there. If we had all the stuff for all these different things all on this same screen here, it would be really cluttered. And I know we have a lot to add. So I'm doing this preemptively because I know by the time we add the granulation stuff, we're going to have a lot more patching. So if we organize it into sub patches, we're in much better shape. In fact, the playback sub patch is going to need room to grow. So I'm going to just leave it like that. Okay. Next thing, we're going to add one more thing. And this is basically just so we don't just have this boring player like this. We have the ability to control the speed of this playback. And we're going to do that with a horizontal slider here. Put horizontal slider, Shift Control J for horizontal. All right, and then we right click on it and put properties. And we want its height. Width is 128, that way. I'm actually going to make it 200. That might fit. And we're going to make it 25 tall, so it's the same size as the toggles. Let's hit apply and see how that looks. That's good. That leaves space for one more thing here that I'm thinking we are going to add. All right. Let's give it, how about the yellow color? The lighter yellow. There we go. And let's do the same thing we did for the label here. Since I changed its size, let's make it 0 by -7. And its label is going to be speed. Give me speed. All right, and here, $0 underscore speed underscore send. Then $0 underscore speed underscore receive. All right. That should be good. Now this is going to allow us to control the speed of playback. Because remember that thing there in, what do you call it? Above phasor, the cycles per second. If you change the number here, you're actually changing the speed. I am going to shrink this down just so I have room to do this. Because I do want to play this back. Actually, I can even bring you in. You don't need to be that wide anymore. And I am going to move you up. Don't forget to continue to do your housekeeping. Look at that. Look at that as just a nice, simple graphic user interface. We'll make it look even nicer, but we have more things to add to it. All right, so we're going to put you over here like this. Now, I'm going to play back, and then I'm going to change the speed. Let's record something that actually I can talk while it's playing back, and you know what's me talking and what's me playing back audio. There we go. So I can talk, and you know who's who. All right. Now, what I'm going to do is I'm going to press play, and then here, I tried to select everything. Control A to select all. What are you doing? Can't I Control A, select all? Yeah, there we go. I've always done it in the past. All right. I'm going to take this out here. I'm just going to display this number so I can quickly do something. Oh, now I'm going to have to record again and get this number in. All right, so let's record again. All right, so we got this number. Everything was working. Play, send. Oh, I am sorry. I wanted to put a number box before phaser, and here I am farting around with this. Sorry, folks. Every now and then, the brain does fart. Here we go. Right before phaser. I want to see this number that comes in, so I could play with it a little bit just to show you what we're going to do. Okay. There we go. So, you see this number? Oh, until we bang it, it doesn't come through. Oh my goodness. I mean, this is just a demo. We don't really even need to do this for the build, but here, let me just make a bang just so we can see the number. No, I have to bang the float box. That's 2 farts in a row there, man. Yeah, we're getting to the end of this lecture. Don't worry, there's just this one more thing to do. But I want to describe this. So we hit that. See, this is the frequency number that's being sent to phaser, so it plays at the right speed. You can change this. And in fact, I'm going to do that. I'm going to type in a lower number while it's playing. You hear that? There you go. So we can change that number, but we want to change it conveniently. All right, so I'm getting rid of this bang. We didn't need any of this stuff. I don't mind the number box being there. But what we're going to change here is instead of normal speed being sent, we're going to send something called playback speed. Now this is going to give us an error at first in the PD window because we're making a receive before we actually have a send to it. But here we want playback speed to be the number that comes here. Normal speed is our baseline number, but playback speed is the one that we can control with this. And this is how we're going to control it. I'm going to go here to properties, and we're going to set the range of this slider from -1 up to +1. Okay. And That should be good. But what we're going to send this is we want it to start off at 0 when things open up. So we're going up here to our PD defaults where our load bang is. And we are going to add one more thing to load bang. Trigger 3 bangs. Because the load bang is the way to tell things to start or to do something when the patch opens. Basically, we want that slider set to 0. 0, we're going to use math to make 0 in between the midway point between -1 and +1. We're going to use math to make sure that selection of 0 plays normal speed. And then the 1 and -1 at the upper and lower ends of the speed slider will have those set to be multiples of the speed. You'll see what I mean in a minute. But here, I'm basically sending a 0 to $0 play underscore RECV. So our play slider will receive this. In fact, we'll be able to hit this message now and see it go to 0, because right now it is sitting at -1. And typically when patches open, sliders will revert to their minimum position. We don't want that. We want normal speed to be our default. So we hit 0 there. Didn't happen. Here, let's check properties. $0. Oh, it's not called play, it's called speed. There we go. Hit that 0. Oh, for crying out loud. This is debugging. This is debugging. Everything we're doing is debugging. $0 underscore speed RECV. That looks right. Let me just copy and paste it. Control C. Command C in Mac. Oh, it's not even sending. I have to make this a send, first of all. S. Then paste that in. There we go. We're good. Hit it. It does it. There we go. You see, now it's at center, which is the way it should start. And we might even make a bang or something that someone can click to get it right back to normal speed. Hello, folks. I just wanted to cut in here. I was going ahead with building the patch, and I thought I paused at one point, but I didn't really pause. And basically, I need to do a quick edit here and kind of pick up with what we're doing. Some of the things I've done already, but I'm just going to take you through. When we left off, we were talking about having a button so that you could reset the speed to 0. So let's take a look at doing that. All right, so what we're going to need to do is put a bang here or something like that. That's Control Shift B as in bang. And we're going to set its size to be consistent to what we have. The reason why this is good to have is just to reset the speed. And we're going to name it $0 underscore speed 0 underscore send. And make it receive just like we've been making them. Speed 0 underscore RECV. There we go. And I'll give it this kind of cyan color. That should be it. Okay. Right about there. I'm going to put in here reset would be a good label for it. And our labels so far have been 0, -7. And there we are. All right, so that is going to zero this out, but we got to put the stuff in. And the most likely place to put it in would be calculations. Now I'm going to show you what I've been doing in calculations when I had the pause mishap right after. But basically what we're going to put in, now I know I didn't have this before, but I'm going to take it out. Yeah, we don't need this. So this is new stuff. Basically, it's good to have a receive here, and this is part of what we're doing anyway. Receive $0 normal speed. The only time normal speed, this number gets sent out is when you've just made a recording. So you want things to zero out to the normal speed and that sort of thing. So what we can do, rather than just sending normal speed out, because we've changed on our playback, and I'll show you this just so you can be sure. We've changed in our playback section here. Instead of it playing back at a rate of normal speed, we've changed it to playback speed. And one edit I did make, I don't know if it was before or after the pause, but it was the only change I made in here recently, was that playback speed is all one word, no underscore, or else it won't work, because everywhere else I have it playback speed without the underscore. Basically, whatever you name these things, the sends and receives need to have exactly the same name. Okay, so I did want to point that out, but since playback speed is controlling it, basically what we want is our playback speed to be the normal speed to start, and then allow you to change it later. Okay? And now here's the thing I also added. Under playback speed, there's a trigger, bang, float. The float is the number. When playback speed comes through, it'll come out of float here, go into the right inlet of this float box where it gets stored, and then the bang comes out this left outlet and into the left inlet here where it bangs it through. So your playback speed gets sent down into phaser where it can update it. So whenever you move that slider on the outside, it will be changing your playback speed. And that's what you want. Whenever you move this slider, you want it to change. Now, going back to calculations, we also want, when a new thing is recorded, we want the normal speed to come up first, and then for you to be able to change it. And also we want to change this bang, or make this bang something that you can click to set it to normal speed whenever you want to. Okay, so let's say you've just recorded something, normal speed comes through. We will see this calculation over here that I've added when things were kind of paused and unpaused. But let's just focus on this first. Basically, when your normal speed is being sent out, you can have it trigger something else. We don't really need the number, but what the heck, we'll get it anyway, out the float outlet. So we have a trigger, float, bang. The float, remember, is a number, so that will send out what our normal speed is here. And then the bang, what we want it to do is just bang this to 0. Now, we could send normal speed to the symbol playback speed, and internally in our playback engine here, where it's reading playback speed, the normal speed that you start off with, in other words, no speed change, will be playing back fine, but it's better for it to display here. So if we zero this out, we will have our normal speed. And so what we're going to do here, and remember that is speed. In this case, it would be receive. We want to send that a 0. So we're going to make a message of a 0. I'm trying to type enu. Okay, no, it just doesn't show the cursor, but it types. So the message of a 0 is going to be sent to $0 underscore speed underscore receive, which is the receive symbol. Well, I can't just type that. I've been doing that a lot lately. We need to make it a send. S space $0 underscore speed underscore receive, RECV. So that sends it to here. All right. So let's do this. I'm going to turn this down, but I'm going to record. And at the end of the recording, let's test this out. It resets the speed. You see, that's what we just put in here. This box displays what the normal speed is. This gets banged to 0, so things should play back at normal speed. Let's test this out. Let's test this out. That doesn't quite sound like normal speed. Oh. All right, so we're going to have to look at this because this is still some new stuff that I had just put in, and apparently it ain't quite right yet. Okay. So what we have up here is a receiving $0 speed send, meaning the send from this. So when we just sent 0 to this, this should have sent out a 0 here. It would be nice to double check that and see what we're getting. So I am going to, don't enter any of this stuff until I go through it from top to bottom because it needs to be tested out. Okay. Now we're going to record again. Hello there. Let's check this out. Now, what we got is a 0 here. So that means the speed send is resulting in a 0. The 0, I assume, got sent here because, yeah, it's resulting in a 0. Here's a way to really test it. Let's change this to something else. And then let's test it again. It zeroed it out. Okay, so our speed is being zeroed out after recording. Now, when it comes into this object here called Moses, and you notice there's a space and a 0 for the creation argument 0, which means any number that is 0 and above will come out the right outlet. Any number coming through that is below 0 will come out the left outlet. Now remember, this slider has a range of -1 up to +1, and therefore 0 is right in the middle. And this is good for ergonomics sake. Someone feels like, yeah, being on pitch, not sped up or slow down right in the middle is about appropriate for it. And you should speed up as you go to the right and slow down as you go to the left. So that's what we want to do here with some math. So Moses, if it's below 0, its range will therefore be coming out of that slider, negative numbers, like starting at 0.01, something like that, going down to -1. And what I did here is I put a swap 1, where that number comes in and goes out the right outlet, and the number 1 goes out the left outlet. We've used this before. So 1 gets added to whatever comes through here. So then when that changes this, that math changes this. So if we go just a little bit left and we're at -0.01, that gets changed to 1 plus -0.01 is like 0.99, positive 0.99. Conversely, all the way down, -1 plus 1 equals 0. So this would be like a range of 0 to 0.99. All right, so that's kind of going the opposite direction we want. We kind of want it to go down from 1, well, not the opposite direction of what we want. Well, this is what I did math-wise afterwards. I then added plus 0.01 to it, so it couldn't go down to 0. Basically, when you're going down all the way here, it's going down to, at the very least, 0.01. And then up here, it's like 0.99 or 1, as the case may be. Something in that ballpark. So basically, after that gets added, it gets multiplied by normal speed, which is that value coming through. So we're like multiplying it by a percentage. The lower the percentage, or the further to the left the slider, the lower this number gets. And therefore, the slower the playback will be. And then the higher it gets, but still below 0, the closer to the normal speed it should be, because the closer to the number 1 it would be. And then I have it going into here, where we have 0.406 as a result right now. But that's normal speed being multiplied by it. And normal speed is 0.417. This is 0.406. It's not exactly normal speed, but it's close to it. Let's hit reset and see what we get here. 0.406, 0.417. Now, I'm wondering why it's not getting exactly to where it should be. Well, here's a potential reason. No, normal speed is going into the right inlets of these multipliers. Like basically when a number gets calculated after recording, it gets stored here. That's fine. It doesn't need to update. These numbers need to update as the speed changes. But the whole thing is right now, speed send should be receiving a 0, and it is. I think I know what I need to do. I need to have these two sides not interfering with one another. And this is how I'm going to take care of that. Oh, I didn't explain the right side and what I did there. I should probably do that. But the math on the right side is, on the right side of Moses, where it's 0 and above, it goes to a times 3. Where basically whatever's coming out gets multiplied by 3. Let's say it's 0. Well, that equals 0. But then it's plus 1. So we're saying the bottommost number that can be from this side is 1. So when things are zeroed out, and a 0 comes through here, it should be initiating this right side, and it should be multiplying by 3, making it 0, because it's 0 times 3, plus 1, making it the number 1, and multiplying that by normal speed, which means 1 times normal speed is whatever normal speed's supposed to be. But it's not coming out that way. I have a feeling when numbers come through here and numbers come through here, I have noticed in the past that sometimes that could cause a little bit of interference with one another. So we're going to add a little something here to fix that. What we're going to do is lower these down. And we're going to put here a trigger, float, bang, bang. And we're going to need 2 of these. Basically, the numbers are going to come through here. They go out the float outlet, and that's just fine. We want them to come through. But these 2 bangs on each trigger are going to do something else for us. Okay, and I'll show you what that is. Down here, we're going to put 2 spigots, is what they're called. We've used this in the last season of this series. Series 1, Series 2. It's like Season 1, Season 2. Spigots are basically like valves. Things go through their left inlet, and the right inlet receives a 1 or a 0 that either turns them on or off. So this one's going to come through here. Basically, I'm going to make sure that there aren't numbers flowing through the other side when, Moses is supposed to split the number stream. And basically, it should be going through one side or the other. And I think technically it does, but sometimes there can be interference or something like that. I don't know. I just find that in some instances in the past, when I've done this, it's cleared up problems like this, where I'm taking some math being done on either side of a chain of math, divided up by Moses to begin with. I've just found that this has helped. Okay, so if we're coming out of the right side of Moses, we want this bang to turn off the left side of Moses. And then the next bang over the second one to turn on this Moses. And then here, not Moses, spigot. And then here we want the first bang, the rightmost bang, to turn off the other side. And then the next one that happens, going right to left, will turn on this side. Now let me see here. I want to see, do we get our thing? When I record this, we should get the right value for normal speed. All right, so normal speed is coming through. There, let's see what comes out here, 0.417. And over here, that's what it was last time. But no. Normal speed is coming out as 0.150. It's zeroing out the speed slider, which it shows here. This 0 should be hitting here. Okay, let's do this. This is why some number boxes can be helpful. Let us see here. But isn't it funny, 417 was what it was supposed to be last time. So let's put this number box in here to see what's going on. Sorry this is taking so long, but this is part of the process. The more you get practice at this, the better. Okay, let's check now. Normal speed is 0.676 there. 0.676 there. We do have a 0 here. Let's hear if it plays back at normal speed. It is not. All right. And so that's playing real slow. That doesn't make any sense whatsoever. Down here, it's saying it's playing back at 0.158. And up here, normal speed is this. Why is this getting reduced so much? I'm going to have to pause the video. Hopefully this time pausing does work right. And I'll unpause at the right time. Okay, we are back and got it fixed. And I found out what it was. It was something that, when you get into doing things in PD, after a while, there's some mistakes that you end up still making, even though you shouldn't anymore. All right. So anyway, the math and stuff was all right. I basically found out what it was. So yes, you do receive your $0 speed, send here, comes through. You don't need the number box. That's just mostly for, testing things out. So I'll get rid of that. And then over here's Moses set at 0. That means the left side, the math worked out. I'm getting rid of the trigger bangs. It turned out that didn't need to happen. Sorry, I was just thinking, well, I've had problems in the past where this has solved it, and not this time. Okay, let's see here. Are these just number boxes? Yeah. Well, I mean, they're not needed. So, but basically the left side of Moses does need to go to swap 1. So 1 gets added to whatever comes in. Remember, it's a range that's going from negative 0.01 or approximately something like that down to negative 1. So when you add it to 1, it now basically becomes a range of 99 going down to 0. You add 0.1, so it doesn't ever go to 0, so you never get a 0 value. You could probably add some higher numbers than this and see how they work out for your slowness range. But I like to be able to slow things down a lot, and maybe we'll experiment with that real quick here in a moment. But there we go. That's what that is. And the right side, multiply it by 3, add 1, so that way the range becomes 1 to all the way up to 4. So we're basically multiplying the normal speed by 1 up to 4. The 0 point in the middle is now gone. Basically, it's at minimum going to be a 1 and can go up to 4. All right, and then that gets calculated and pulled in here. Here, let me make it look nice. We don't need all that extra space anymore. It was simpler than I made it out to be. Imagine that. And then I just put the number box here so I could see what was coming out. And then when I saw this match up properly, then it was cool. We don't really need that anymore. Here's what the problem was. Both of these go into the left inlet of this multiplier here. So whether it's going above or below in Moses, both of those chains of math are going into this multiplier's left inlet. And then what I needed to do was here where normal speed comes in. We no longer need to see it there, but I don't think it helps to really get rid of it. But trigger bang float, that sends this number out the float, the rightmost outlet, into the right inlet here, and a bang to the left inlet of the multiplier, which forces it to calculate. Basically, after recording, I was like thinking, after recording, normal speed comes in, it'll come in, it gets stored here. It only needs to get stored here. The math happens when this happens. Well, if nothing's coming through here to bang this through, the math doesn't happen. And that's why I was getting the most recent speeds before I tried what I tried. So now, no matter what, when normal speed changes, it will do the calculation and send that out as the playback speed. So we're always good on that front. And remember, this is down here that when normal speed comes through, it also makes sure that our speed slider is set to 0. Okay, and that would even come through again here, or at least I was expecting it to come through here again and set this to 0. And that's why I thought the calculation would happen here. But maybe, let's check something here. Maybe I have a typo. Receive $0 underscore normal speed. Okay, and yeah, we've been getting it here, so that does work. But the bang here bangs a 0 message to send at $0 underscore speed underscore RECV. And let's make sure we're set right over here, because this is where that should end up. $0 underscore speed underscore RECV. Okay. Now its send is $0 underscore speed underscore send. So I was thinking when normal speed came through, it should be sending that 0 right back through here, where it would come on this side of Moses. Oh, I hooked this up wrong this time around when I was changing things out, and get calculated here and bang everything through, because it would have already arrived here as well. But somehow that whole chain of events was not going through. Somehow the signal going through the slider was not going through. But anyway, it's working now. So if it ain't broke, don't fix it. So what I'm going to do here, let's test this out. Let's pretending like we're starting from the beginning. Let's pretending like we're starting from the beginning. Let's test this out. Oh man. Before I unpaused, it was working. I was just playing it back and things were just working for me. We're not going slow now. What's going on here? Maybe when I was taking out number boxes here, I probably screwed something up. Okay, go swap 1 plus. Yeah, 1 gets added to that, and then you add that to it. That goes into the right inlet here. That would be a problem. It's supposed to go into the left inlet here. So when I was taking out those number boxes, I was being careless with my patching. Just like these need to go in through. So basically what was happening is while I was moving this slider, the faster speeds were coming through, but the lower speeds on the left side of Moses were not coming through. Let's zero it out. This reset button is supposed to be resetting speed. Now I'm getting all the slow speeds, but not the... All right, let's start from scratch. Let's start from scratch. Let's start from scratch.
Let's start from scratch. Let's start from scratch.
From scratch.
Let's start from scratch.
Let's start from scratch. Let's start from scratch. Let's start from... The reset button is not working, so let's fix that. That's $0 underscore speed 0 underscore send. And same thing for receive. Oh, I think that was something that I was going to put here into here, but I never did. That would be why it doesn't work. I never did it. Okay, so all we do is receive $0 underscore speed 0 is the label underscore send, and basically what it's going to do is send a 0. So I just make a message box right afterwards, 0, and send that to send $0 underscore speed 0. Oh, no, we're not sending it to that. This goes to the slider there. And the slider's name is speed_receive. Okay, so we can test that out by doing the following. Let's start from scratch. Let's start from scratch. Let's start
From scratch. From scratch.
Start from scratch. Let's start from scratch.
Let's start
From scratch. Let's start from scratch. Yeah, I like to be able to go really low. So we can do that kind of stuff. But there is a really,
Let's start from scratch.
towards the bottom of
Let's
the
start from scratch.
slider, there is a bit of a section there where you don't hear much of anything, probably because it's getting too low. Let us try a 0.1 as the bottom. And see how that works.
Let's
Start from scratch. Let's start from scratch. From scratch.
Let's start from scratch. Let's start from scratch.
Let's
Let's start from
start from scratch. Let's start from scratch. Okay.
Let's
I
start
think I'm
from
good with
scratch.
that. You can play around with values to get different speeds and stuff, but I think for granulation that will be good. Now, what I'm going to do, just to help out here, just at the end, here's the calculations window as it is now with everything fixed. Here's the playback window. I think there's one thing I want to fix in that. And of course, if you're following along, you can pause the video to look at these screens. This playback, I don't think is going to fit on screen at the same time as everything else. But I could cover up my main GUI. We haven't done anything with that in a while. Oh no, this isn't that tall. There we go. We got the whole thing on there. Those are the main screens that we've been working with, calculations and playback, in trying to get this whole system work. The recording hasn't changed at all. Although I'll open that up so, you have windows to debug with. So you could like freeze frame it, pause it, and debug your stuff. But there is one fix that I want to do here. Now, when we're playing, what happens is it receives, playback speed here as a multiplier, but basically the play button comes in, and what happens is it bangs here. It bangs whatever is stored here, and all that, but it doesn't always start from the beginning. It's like wherever phaser left off at, it seems to be where it starts. So what I'd like whenever you press the play button, for it to also just go to the beginning. And so what I'm going to do there is, let's see, we have select one. This is for playback starting. Let's add an extra bang in here. Yeah, let's make this the rightmost bang. So basically it does this message before it even turns on sound. Okay, so sound gets turned on afterwards because this will be further to the right. Just so things can be seen a little bit more clearly, move you down a bit. I don't like patch cables to be covering each other up. So maybe if I move you up a bit more so you can see where things are coming out. Let's put a message 0 here. And there's one way of getting phaser to start right at 0, at the beginning of its phase. And that is to put a 0 into its phase input. Right there. So now it will always start from the beginning. If I play, what are you doing? Did something, I may have, because of, do I have to record again? It should play. Let's start from scratch. For some reason, I had to send speed again. I wonder why. Well, that's something I'll look at for next time to see why. I mean, obviously a value, I changed something and a value wasn't sent, that had been sent before, but let's see here. Oh no. Did what I just add screw things up? This is all the stuff you gotta check. It should just put the phase back to 0, which means phaser starts from 0 and goes to 1, rather than partway through its phase. That should be all that happened, but for some reason, let me see. Let me see if that had anything to do with it. Let's start from scratch. Let's start from scratch. Okay, there's something else going on in here. It looks like normal speed, or what is it? Playback speed. This is not being sent. It looks like this has to be sent, but here it's banging the left inlet of float, and float is always being updated with playbacks. If we receive playback speed, now should playback speed always trigger phaser to start? No, it shouldn't. It should just be stored here. Now when you stop, I see what the problem is. When you stop, the 0 gets sent in. So we need to put in another float box, because playback speed needs to be sent into phaser to initiate it, to get it going every time you play. So that will happen from this one. And I think what we've just added, yeah, this guy right here. I need more bangs here. Actually, as you see, you can hook up multiple patch cables to these bangs, and they will work out that way. I'm just anal. I like to have individual bangs for each one. Let's put you over here with this. And so the first one, the rightmost one, should go to 0. This one should go to, well, that's already hooked up, but no, we should turn on sound after that. Actually, you know what? Let's turn on sound first. So yeah, this rightmost bang allows sound through. The next one goes to 0 here. The next one goes to you here, so that our playback speed gets sent in. It needs to be sent in every time. And of course, the first bang there is already handling the first float box. So this float box stores it, but as soon as this 0 comes through, it clears it out. So you need to send in that number again each time you play. All right, and then over here, let me hook you up to make sure you always start at the beginning of the phase. So there you go. Let's test it, and then we can say, all right, that window is good, basically in this debugging session here. Now in the future, I'm going to debug as I go through, and not necessarily just have something at the end, some spot where people fast forward to just to get screenshots, just to do it. I mean, I like to teach and not have you like just copy, paste, put it in and not know what you're doing. As you see, it can be very complicated. So the more you know about what you're doing, the more you understand the subject. So here we go. All right, I think we need to start from scratch here. Let's start over from the beginning. 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 Oh, all right. Every change you make, it causes another thing to go wrong. Oh, boy. Yeah, see, this is coming in here. It's being banged through only when I think what I need to do here, and that now this will be kind of hard to see. I think. Let's put you down here. But what you're going to have to do is on the fly for the speed to change. Playback speed is going to have to go through the left inlet here. I'm even wondering why I have the float box here. I guess just to bang something to start. Because when it's time to stop, this gets banged in. I'm going to try and go without it. Both of these float boxes. So does this even need to bang? I have an idea here. Yeah, let's have a float box. Because what it does is it also stores the number. when you put it through the left inlet, it goes straight through. So it will go through and give phaser its speed. And when it gets banged here, it will go through and give, once again, because it's also a storage container. All right, let's try that now. May not need all these bangs. How come?
Let's start over
From the beginning.
Let's start over from the beginning. Let's start over. Let's start over from the beginning.
Start over
From the beginning. Let's start over from the beginning. Let's start over from the beginning. Let's start.
Yep, now it's working right. Okay, so it looks like I can get rid of some of these bangs. I just like to keep things as clean as possible. Just what is necessary. And yeah, to make sure we start at the beginning, we do need that 0 there for the phase. This is why you got to watch all the way through, folks, because there's reasons for all the different decisions that are made, and you learn from those reasons. That's how you really get to know a subject. And so basically, yeah. Move that over like that so it's easier to see this. But yeah, you're plugged into the left inlet, because that way, whenever the playback speed changes, it always goes through. But when it's time to start playing, it bangs it through because this float stores it. And rather than having this 0 going into there, just have it go straight into this number box and go into phaser. So that way it doesn't change what's being stored in the float box. All right, folks. So what I'm going to do now is to debug. Here's the current version of Playback. You can pause the video. Check that out. Here's the current version of Calculations. You can pause the video. Check that out. And then let's open the other ones here. We have Recording. I'll move it down. I'll move it down here. There's the current version of Recording. You can pause the video and check it out. And then we're going to do the defaults. And then what I'm going to do is one last debug of opening it up from scratch and seeing if it works. There we go. There's the default. So you can pause the video and double check that. Okay, so in the future, I'm going to try not to do things just like that. I want to make sure people do listen to this all the way through, because it is important in knowing what mistakes I do make and why, and thinking about it. So I'm going to close that, open the folder. Now, what are you doing? There we go. There we go. So we're going to test it right from the start, as if somebody just opened this software. You should be able to record right away and then stop it. You should be able to record right away and then stop it. You should be able to record
Right away.
And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it. You should be able to record right away. And then stop it
Stop it. You should be able to record right away. And then stop it. You should be able to record right away. and then stop it. You should be able to record right away.
And then
Stop it.
you should be able to record right away. Then stop it. You should be able to record right away.
There we go. So there we go. Everything is working. So I'm going to get a screenshot for next time. Next time we are actually going to then granulate this sound. And then the time after that, the third episode, we're going to be improving the GUI and making everything more like an instrument and stuff that you can use. But this is probably, out of all of them, maybe the longest, just because we'll see. But in any case, thank you for joining me, and I'll see you next time. Until then, take care and stay free.